Okay, this video is going to talk about solving systems of linear equations using substitutions. Now, when we talk about linear equations, of course, we have two variables. So when we have two equations, we can solve for these variables. And the way we do that in substitution is where we use one equation to substitute for one of the variables. So let me show you what we are talking about. I'm going to take two equations, y equals 2x, and our second equation is 7x minus y equals 15. Okay, so, I really want another color, so I'm going to attempt to pause. Well, no, actually, I'll just keep talking. I'm going to go get a red pen. Sorry to have left you hanging. I should have actually left you with somebody, but just really didn't get to that point. Okay, so I've got my red pen now. So here, y equals 2x. So here we have 7x and we've got a y here. So if I know that y is equal to 2x, if I take this y and I replace it with 2x, because after all, y does equal 2x. Now let me rewrite this to 7x minus 2x equals 15. Hopefully you can see that it's the same thing, and we know that 7x minus 2x is 5x equals 15. So you can see that it's quite an easy substitution. Now we're going to divide both sides by 5, and we get x equals 3. So now I know what my x value is. Now let's go back to black. I think it's easier to see. Now, if I go back to this very first equation up here, y equals 2x, I already know that x is 3. So at y equals 2 times x, and x is 3, 2 times 3, that means that y is equal to 6. And my solution is therefore 3, 6. Without having to graph anything, I know that the one solution to both of these equations is the point 3, 6. Now, let's make sure that we have done everything right. We know that 3, 6 works for our equation y equals 2x. Let's just go ahead and make sure that it works in our second equation. So I'm going to take our second equation, which is 7x minus y equals 15, and I'm going to use my 3 for my x, 7 times 3 minus, and my y is 6 equals 15. Okay, we can see that now. And this is 21 minus 6 equals 15, and I think that we all agree that 21 minus 6 does indeed equal 15. So let's look at maybe a slightly more complicated problem using the same techniques, and we've got 6y plus 8x equals 28. And we've got 3 equals 2x minus y. Now, in this case, we don't have any easy substitutions. So basically what I'm going to have to do here is I'm going to create that easy substitution. Okay, I'm going to go ahead and add y to both sides. It just seems like the most prudent thing to do. That's going to give me y plus 3 equals 2x. Okay, and then I'm going to subtract my 3 to get my 3 on the other side. So you have to do just a little bit of calculations here. You get y is equal to 2x minus 3. But now I do know exactly what y equals. So I'm going to come back up to this first equation, and I'm going to say 6. Now I have a y. Yeah, I wrote it badly, but that is indeed a y. And y equals this. So 2x minus 3 will replace my y, plus 8x equals 28. And now I'll just continue the solution using the distributive property. We've got 12x minus 18, excuse the bell, plus 8x equals 28. 12x plus 8x is 20x minus 18 equals 28. Move this on down and give us a better view of what's going on. Adding 18 to both sides, we end up with 20x equals 16, 2, 3, 46, dividing by 20, and x is equal to, now in this case you can go decimal fraction, whatever. I'm going to go the easiest way. 20 will go into 46 twice, with 6/20, which is 3/10. So 2 3/10, or 2.3 is my x. Now I go back and I solve for y. Now remember, we started with two equations. This one I manipulated, but if I go back to the original, I can actually use that original equation, which I'm going to do. So I'm going to rewrite it. So I've got 3 equals 2x minus y. We now know that 2x, I'm going to use the decimal version, 3 equals 2 times 2.3 minus y, okay, 3 equals, and this is 4.6 minus y. If we subtract 4.6 from both sides, this will give us a negative y on this side, and a negative, what is that, 1.6 on this side. Multiply the whole thing by -1, and y is equal to 1.6. So coming back up here, I can say that my solution to this system of equations here is my x of 2.3 and my y of 1.6. Now, one of the things that I want you to notice is that by not graphing, we've been able to get to an exact solution here. This is why sometimes you will see problems that are set up for you to graph, and sometimes you will have them set up to do in other methods. We would never be able to identify that point on a graph. So, so it is better that we solve it some other way. So a bit of work to get there, but not difficult. So hopefully, I think that what you'll find is that they get easier with the problems that you do. So, so just be ready to do a bunch of problems so that you can get to be quicker at them as we go along. Okay, thanks.